Good afternoon, everyone. You are welcome to this lesson. So today we'll be analyzing the slab. We'll be doing the calculations, then talk about the loading. Then if time permits, we will design for panel 1. So without wasting our time, let's quickly move to the panel. Yeah, this the design we are talking about panel 1. Panel 2, panel 3, panel 4, panel 5, panel 6. So today we'll be working on panel 1. Panel 1. So in this panel, we also tell you the bending moment coefficient of this panel. Is taken from BS code. I told you that we are making use of the BS 8110. So this type of slab, the bending moment coefficients will be obtained. This is a case 4, where we have two adjacent edges discontinuous. The two adjacent edges discontinuous. So we get the bending moment coefficients for short span and long span. So we'll take you there. We'll have the bending moment coefficient. So first thing first, now we have to calculate for the load. We are talking about slab design. Slab design. Then you have loading. The loading, we have a concrete. That's the loading now. That's UDL, ultimate design load. This ultimate design load, you see concrete own weight will be given as, then the thickness of our concrete is 150 mm. Divide by 1000 to give you meters, then times 24. This is concrete own weight. This one will give me 3.6 kilonewton per meter square. Alright, then we have finishes. These are dead load. Finishes is taken to be 1.2. It's taken to be 1.2 kilonewton per meter square. Then we have partition allowance to be 1.0 kilonewton per meter square. So if you calculate this one will give me 5.8 kilonewton per meter square. This for the dead load. This is dead load. Denote this as a GK. That's the dead load. Then for life load, QK. From our previous lesson, we said that we are going to take 4.0 kilonewton per meter square. Alright. Now, for us to get our ultimate design load now, that is ultimate design load, can call it F, is equals to 1.4 GK plus 1.6 QK. Alright, now this is equals to 1.4 multiplied by 5.8 plus 1.6 multiplied by 4. Alright, so we'll get our calculator. Calculator, get the calculator here. All right, calculator, we have 1.4 times 5.8 equal to, we have that's 8.12 plus, and we also have 1.6 times 4 give us 6.4. So if you compute the two together, we have plus 8.12, that will give me 14.52 kilonewton per meter run. Now, this is the load on this particular slab, panel 1. All right, this is the load on panel 1. So we have to also talk about the effective depth, which is D, effective depth. Which is normally taken as D equals to the depth of our concrete is 150 minus the concrete cover, we said is 20 minus 12 steel over 2. This will give me 2124 millimeter, which we are going to be using, because from this concrete we are going to give a spacing of 20 millimeter concrete cover. So that is that for the loading on this slab. We have our F to be equals to this, and we have our effective depth D to be equals to this. Then this now will now lead us to the analysis of panel 1. You cannot call it panel reference, you cannot call it panel 1. Panel 1. So in our next class, we'll be talking about panel 1, because some people have said that the class is long. So if you check the time now, it's already 7 minutes. So let us call it a day in this particular class. Thank you and God bless.